Right triangle trigonometric application problems. So these are real life situations which we are discussing now. Example 5. When poured into a pile, gravel will naturally form a cylindrical cone with a slope of approximately 34 degrees. If a construction site has a room only for a pile that is 85 meter in diameter, how tall to the nearest meter will the pile be? So in any such problem, you should at least read it twice, try to understand the situation, make a sketch, and then solve the problem. So here we already have a sketch for you. So it says, let's read it again. When poured into a pile, gravel will naturally form a cylindrical cone with a slope of approximately 34 degrees. That means when you're pouring sand or gravel like this, then it forms like a cone like this, right? So it's kind of like this. So when you're pouring something like this, it forms a cone like this. So it becomes like this cone, right? So as you pour, this cone can expand, go horizontally up, right? Now it says, if a construction site has a room only for a pile that is 85 meter in diameter, that means from here to here, it could be 85 meters, right? So this circle thing which is formed on the ground, it could maximum go to 85 meters as diameter. How tall to the nearest meter will the pile be? Then how tall will this height be, right? From here to here. So that's the diagram for us. Now let's try to solve it. This angle is 34 degrees, that is the slope. When we say cone with the slope of approximately 34 degrees, then it looks like a cone, right? And this is the slope of the cone, right? I've not drawn this side, but you can always correct this anyway. So this angle is 35 degrees for you. Now to find the height, what we know here is, we know diameter, and so we can find the radius, correct? So radius is going to be half of diameter, and height, slope, and radius can be related with the slope, right? Tan theta, tan of 35 will give us the slope. So we can use that tan 34 and say, well, tan 34 equals to height over radius. And how much is the radius? Or this side. So radius has to be half of it, right? From the symmetry, these two sides will be equal for diameter. And so this is going to be half of 85. So let's calculate the radius here. So if diameter equals to 85 meter, then radius equals to 85 divided by 2, okay? So that is equals to 42.5 meters, correct? So we can use radius of 42.5. So we have height h and radius here as 42.5, okay? And so from here we can cross multiply. We can multiply both sides by 42.5. It will cancel out. So we can say height is equals to 42.5 times tan 34. Okay, so let me write like this. Height equals to 42.5 times tan 34 degrees, correct? Now use your calculator and write down. And don't forget to write units, which are in meters in this case, okay? So we have 42.5 tan 34 equals to 28.66. So that is the height in meters, which is going to be possible in this particular case, right? You remember tan theta is opposite over adjacent side. So whenever in a right triangle, this will be a right triangle here. In any right triangle, if if you are interested in opposite and the adjacent side, the trigonometric ratio to be used is tan theta, right? Tangent. So that's how you can get height of this pile, okay? Thank you.